lesson 3 for year 13 physics. It's on internal resistance. Now, batteries are made up of chemicals, and these chemicals, which is the electrolyte and the electrodes, they have some resistance, which we call internal resistance, and the symbol is a little r. Now, EMF, or the electromotive force of a cell, is its claimed voltage. This is the amount of energy that each coulomb of charge gains when it enters the cell. If a voltmeter is connected across the terminals of a cell, the measured voltage will be its EMF when no current flows. So, internal resistance. When there is an external load and a current flows through the battery, some of the energy that each coulomb of charge is gained while entering the cell is lost due to its internal resistance. We say that there is a potential drop or a voltage drop across the internal resistance. The voltage, which is the energy per coulomb available to the external circuit, is called the terminal voltage. A cell with internal resistance is represented like this. So the dotted line says that it can't be separated. The relationship between EMF, terminal voltage, internal resistance, and current. Now, the current on the circuit depends on the total voltage and the total resistance. So that's your current. You rearrange and you get that formula, and there's your EMF, your current, your terminal voltage, and the IR is the voltage drop across the internal resistance. Now, there is an experiment which can be done to measure internal resistance. So if you have a rheostat, an ammeter, and a voltmeter to measure the terminal voltage across the terminals of the battery when a current is flowing, what you're going to get is a whole lot of points. This is some data we did in class from an experiment we did in class, and you kind of get a line like this, but if you extrapolate, and you'll see that the intercept on the y-axis or the voltage axis is the EMF, and the gradient of the graph will give you the internal resistance. Now, what we can see from this graph is as the circuit current increases, the terminal voltage decreases because there is a greater voltage drop across the internal resistance. So new batteries have a low internal resistance and old batteries have a high internal resistance.